Hello everyone. I have received some requests for creating minimum viable products or MVP for machine learning projects, and I have decided to give some examples about that. So first example that I'm going to talk about is how to predict weather temperature using some time series features. These features could be, for example, pressure, wind speed, humidity, and some other features that you're gonna see in the example. And based on these, we wanna predict what is the temperature looks like for next hour or next 2 hours or next a window of time that we wanna consider. So the big process is gonna be we wanna create some proof of concept, or we call it POC, and this is usually on a Jupyter notebook that you can analyze the details, you can play with the graphs and visualize it, clean your data, and create that proof of concept that works for you and your client or your boss or your manager, whoever that you are working with. This step you should be able to communicate the results with your managers and whoever you work with, and if they say that these level of accuracy or this concept looks good, then you can go to the next step, which is usually creating minimum viable product, which usually is to convert your notebooks to Python files, and then you need to create like classes, objects, clean your data in Jupyter Notebook to use more methods, functions, and efficient way of doing things, like minimize number of for loops and some little details about that we are going to talk about in the next session. Okay, now let's dive into the data set. I've imported some libraries that we're going to use in the later sections, and importing the data set from local path. If you see, we're going to have some numerical features like temperature, min, max, pressure, humidity, and some objects which are usually strings. And we should deal with these. Some of them should be converted to numerical values, and some of them could be probably dropped if they are not relevant. For example, let's look at this city name and see, are we predicting for all cities or just one city? Probably it's wise to start with just one city, and then if we want, we can go for all cities. So if you look at the frequency of city, how many observations we have for each cities, we can use value counts for that. Okay, pretty good distribution among different cities. We can select just Madrid for this purpose. We want to predict the weather for Madrid. It's a famous city. We can filter the data frame by using query. The feature name, is city name, and we want that to be equal to Madrid. And we can take a look at the tail of the data frame. Which now it's all Madrid. And it is better to use copy when we are copying part of the data frame to the new variable name or new data frame. Now let's look at the first feature, DTISO, which is the timestamp or time index that we're gonna make it a new index for our data frame, but it is in object format, which is string. So first thing, we wanna make sure that it is in date time format. Pandas has a nice way of doing it, and it is to date time of your column, and when UTC is true. Now if you look at the info again, you will see that now we have date time, not object. Okay, next object in the list is city name. City name, we're not going to use it anymore because we filtered it for Madrid, and we can move on to weather main. Now we know weather main, this object is string. If you look at the data frame itself, it shows clear or some other values. Let's look at them. Value counts. Now what we're going to do is we're going to replace each of these categories with one number. For example, clear with 1, clouds with 2, rain with 3, and so on. Now instead of having strings, we're going to have values or labels. This is called label encoding or value encoding, and we have a nice way of doing it again with pandas. We can instantiate a label encoder, which we have imported in the first block of the code, and use it to fit transform the column that we are interested in, transforming to values. Fit transform the column, and obviously we want to save it to the previous column. So if we do that and again look at the value counts, now you're gonna see that instead of having string values, we are having numerical values, but the distribution is almost exactly the same. Similar approach with weather description and weather icon. These two, the last two objects, we can use similar code, LabelEncoder, to encode both of them. I just copy paste to save some time. And now if you look at the data type, things are either date time or float and integer numerical numbers. Then we're going to drop this object city name because it's only Madrid. The next thing that we want to do is, if you look at the data frame, the index are numerical. There's a very good benefit in changing that index to these times, date time format. So we're going to set the index to this column because that's going to help us to use many good methods from pandas to either change the frequency, like resample the dates. You can resample for 4 days, 5 days, 3 weeks, whatever, based on their calendar, or you can shift those, and we're going to talk about why we need to shift. So first thing, we need to just set the index of this data frame to this new column, DTISO. We can do that by setIndex method. So for example, you can use data frame setIndex, the column name that you want to change the index to, and in place true, which means it's gonna change the index right after executing this block, and we can see that here. If you execute that, the index now is DTISO. Now we can start thinking of like shifting this, and why we want to shift the data frame or the target that you want to predict. I'll explain with a simple example here. So imagine we have time series data with two features, x1, x2, some numerical numbers which are producing the output 34, 42, and so on. And imagine these are like hourly numbers. Now, this 3 and 8, what in the classical classification or regression, we are saying is like these two numbers are outputting or resulting this 34, and this 212 is resulting 42, and so on. But that's not what we're really interested in for prediction, because that's the current state. What we really want to know, for example, for next hour is 3 and 8 is gonna produce 42. 2 and 12, they're gonna produce the next hour number, which is 39. So imagine we shift these y numbers just 1 hour up, then we can say 3 and 8 they are producing 42, which was the next hour number, or whatever it is. Like it could be temperature or whatever that you're predicting your label and target. So we shift the numbers for how many hours that we want, or how many days or weeks we want to predict for. So with doing that, we change the problem to a classical regression problem right now. So right now, for example, each row is saying like 2 and 12, for example, are leading to 39. 3 and 8 is leading to 42. So if we can model this with any numbers, any input numbers, we can predict the outcome, which in this case, since we know it's a shift for 1 hour, it means we're going to predict 1 hour ahead of time. We can do the similar thing in our current problem. Before going to the code, you see that this last point is null value, and because that we don't know the number for the last point which we shifted. So to deal with this, you can either drop this last row, or you can replace it, for example, with numbers before, like the last point. Pandas has like field forward or backward field that we're gonna show, but that's a thing you need to do. Like if you shifted 2 hours, you're gonna have 2 null values at the end. Now back to code. If we want to shift the output, we can use shift method. Let's say we want to shift it even like 3 hours. So we need to specify hour in the frequency, and we want to do -3 because we want to shift upward, and we want to shift this column. So we need to replace that column with this new shifted value. If we do this and we look at the data frame, you're gonna see that there is a problem. Cannot reindex from a duplicate access. And this is interesting. You're gonna see it with most of the data sets, because they're gonna have duplicate values. And how you need to find those first and deal with those is next. Let's look at the duplicate values first. Like, what are the duplicate values? Because we need to know how to deal with those. You cannot just simply drop those, or you need to first look at those. So we can look at them by filtering the data frame. So the filter condition is going to be inside these square brackets. We want to look at the index of data frame which are duplicated. And it's going to be like this. So these are the values that are duplicated in the index of that data frame, because this is always the filtering condition for the data frame that comes first. Now, if you look at it, it's like almost 1200 rows are duplicated. Now you can randomly filter for any of these indexes that are duplicates and get all the duplicate values for a specific one and study those, like why these are duplicate. Are they really duplicate, everything is identical, or maybe some of these numbers are different, say temperature is different for those duplicate, but everything else is same, or some of them are a little different and some others are totally duplicates. And based on your domain knowledge, you need to deal with this, like how you're gonna consolidate those numbers. You have, for example, 5 very similar numbers that you wanna maybe take their average and come up with just one number for that hour, because assumption is each hour should have one unique number. But since that's not the topic of this video, I'm gonna assume that we want to keep just the first one and drop all other duplicate values. For that, we can simply revise this condition and say not duplicate. So I added this tilde sign to say I need the ones that are not duplicates. And if I execute this, I'm gonna see that now I have this large original number without duplicate values. One thing I wanna point out here, if you just do Shift Tab, it's gonna show you the results for the duplicate method. Some help regarding what are the parameters for that duplicate method. There is this keep here, which you can select first, last, or false, and the default for this value is first. So what it means, like if you select the first, which is the default, it's gonna only keep the first value. If you choose last, it's gonna keep the last duplicate, and if you select the false, it's gonna mark all the duplicates as true, which is gonna drop all the duplicate values. Now we can replace the data frame with these non-duplicate values, and now the data frame doesn't have any duplicate values. Now let's go back and do this again, because we had a problem here because of the duplicate values. If you run this time, it should be fine. And if you look at the last 3, these are nan or null values, because again we shifted 3 hours. We can fill these missing values with fill NA method of pandas, which we need to specify which method we want to use, and we want to use forward fill. And if you do that, we can save it to, we should save it to the old column or replace it, and we can take a look at info to make sure it is filled correctly and there's no missing values. If you look at it, the temperature now doesn't have any missing values. And finally, we can move to the modeling side. So let's say target variable, we call it target, and we know we want to predict the temp. And for all other variables, we can use the columns, all columns, but drop the target and city name. We discussed this, we don't need this because it's only one city and we are predicting for that. And if you execute that, you see these are gonna lead to these list. Now we can name this features, for example, features. Now we can slice that slice the data frame and convert it to NumPy array, because it's better to use NumPy array with most of scikit-learn fit and train methods. So we can slice based on features that we selected here and say values, which is gonna convert it to NumPy array, and y is gonna be similarly method with target. And values. I think it doesn't need parentheses. Now we can select any regression method, because this is a regression problem, classical regression problem. Let's, for simplicity, use linear regression and see how it performs. So linear regressor, I'm just instantiating it, any name you can use. And we have imported in the top section, which is linear regression. I'm gonna instantiate the default hyperparameters, if you will, and then I'm gonna, let's first instantiate it, and yeah, it looks good. And then I'm gonna fit it with X, and so before fitting with X, let's split the X to train and test, because we want to evaluate how it's going to perform. So there is split method, train and test split, which takes these X and Y values and produce train and test values. If you look at the documentation, this method is gonna produce the outputs in this order: train, x test, x train, x test, y train, y test, and the arguments are x, y, and test split, test size, which is a percentage, or like, say we want to have 20% test size, so we need to specify 0.2. If we execute this, you can test the shape of each and make sure that the split was successful. But anyway, now you can use these train and test data sets to fit and evaluate the linear regression that you're going to use in this session. So let's use fit, linear regression fit. I'm going to fit with x train and y train. Now, the linear regression that we defined here is trained on these input and output data. Now we want to know how is the performance on this, how we can, is this good for predicting the future values or not. For that we can use test data, which x test and y test, which we haven't used it in the training or fitting section. So if that is going to perform well on this unseen data, we can almost conclude that the skill of this model or linear regression is good on predicting unseen data for this data set, and it's going to perform well in the future data for weather prediction. Okay, let's look at the evaluation side. For the evaluation, we first need to predict some unseen data. For that, we need to use predict method, and we want to use the model that we trained, dot predict, and the unseen data, which for now is test data. If we do this, we're going to receive some predictions. And these are, we can store them in, say, yPredict. That's usually the convention, prediction or ypred. And now we have ypred and ytest. So these are the ground truth that we know exactly from the data set that we had. And these ypreds are the predictions. So we can compare them one by one and see how good or bad we are doing with the predictions. For example, even like the simple way can be just print them out. Very naive way would be just print them out and look at them, see how close they are. For example, the first one you see 305 versus 302. The second one 277 point. The second one looks even better. Third one and fourth. But if you want to look at everything together, you can use mean squared error matrix from scikit-learn, and add all the which basically tries to average the squared error of all these points. So it compares 302 with 305 and finds the squared error for that, and the second one and third one, and then average them all because of the mean that we have here. And if you do that, and it doesn't really matter the order here because it's squared number. We want to compare the errors for this, and if you run this, it's gonna have a number like this, 10. But this really, I don't like it directly to use because it doesn't have a good feeling. Like you don't know this is a high number or small number because it's squared error, and it's better to take the root for this quantity and go back to the same unit that you had. Like these numbers apparently are in Kelvin. So if you do the root, now you know that this number is in Kelvin. So 3 Kelvin looks acceptable, and that's obviously different for your application. You need to check these errors are acceptable for you at the moment or not, and if not, you can go back and change the model or change the parameters that you have. Remember, we didn't touch on hyperparameters or parameters tuning. You can play with these numbers. There are so many things that you can do, but that was not the main focus of this video. Okay, we covered a lot, and we can add so many other steps that I'll add some of them here that is going to help the Jupyter notebook and your train and prediction process. But let's say we are satisfied with what we have done in this Jupyter notebook, and now we want to create some minimum viable product, which is gonna be scheduled either in server, cloud, wherever you want to like train and predict some quantities, like real product, Python product that you want to deliver to your manager. In the next session, we're gonna first clean up these codes and create a train and predict Python files. The first one is gonna read the data, clean it, and train the models, and it's going to save the model to a local or somewhere else that you want, in cloud, S3, or wherever the location is. It's going to dump or drop the model there, and the prediction is going to load the model and the data, and then it's going to produce the predictions, and later it can write the predictions to somewhere else. So we're going to do just simple things just to understand what is usually minimum viable product that we can deliver. Okay, I've created train and predict.py files, and I'm going to briefly describe each one. For the training, what we want to do is first load the data, clean it, and then move to training and saving the model. So I have created two functions for that: load clean data, the first one, and the second one, train model. So the first one takes the model name or path and the city that you want to filter the data for, and it returns training and test data. And the train model takes the training data, which is X and Y, and returns the model. It also, you're gonna see, it saves the model inside the method. And there is evaluate a model function also, which looks at the model and the test data and produces root mean square error, and it prints it. So remember, this is not the only way you can do it, but you're gonna see you can, for example, look at more spaces and print more root mean square errors for different configurations, and then decide like the best one and save that model, or different philosophies that you can follow. But this is just a simple, very simple, minimum viable product or way of doing things. But let's look at quickly what is this load clean data. You already saw most part of it in the Jupyter notebook, but we first load the data. This can be from S3 or any location that you have. Right now it's a local file for me. Then we filter for the city. So you can use @city name that is going to come from the function argument, and it's going to filter it, and then it's going to change the date time, string format to the date time data type. Then we're going to encode the categorical features as we discussed earlier. We had three that we liked to convert to numbers, and we're gonna instantiate them first, and then we're gonna replace those next. And this step is extra here because you want to do the same thing in the predict file later, right? We want to use same numbers. For example, if for one of these categories you've used number 5, you want to use number 5 for the same category later on in your prediction numbers that are coming real time. We didn't do it in this example, but if you had scaling scalars, like your numbers are not in the similar ranges and you want to scale them, when you are doing scaling in the training, you must save those scalars and you're gonna load them again in the prediction, because you want to do again exactly same things that you are doing in the training in the prediction side also. Later we change the index to date time, and we shift. You've seen already these why we shift. And finally we create inputs and outputs, and train and test split, which is gonna return training and testing data set. We already saw these in the Jupyter notebook. You can go back to that section of the video. So this function, we know what it does, and it finally returns train and test functions, datas. Later we use train model function. And for the train model, it's going to be easier. We get the data and we use a linear regression in this example, and we fit the data, fit the model with the data, and then we dump it to a local place. In my laptop I've done it, but you can do it. You can use sophisticated methods to send the data to S3, for example, in Amazon or Azure or wherever you are using in the cloud, and it can have multiple versioning, like you want to keep record of like last 3 models. The last method that I'm gonna look is evaluate model, because in this function, we train the model and we return the model. So this is the model that we return here, and that's the trained model. Now we can use that trained model and the test data, which is not seen by the model. This is brand new data for the linear regressor that we have trained, and we want to evaluate the model. So the evaluation is, we first predict with the test data. We use the model and we predict for the test data. We save it to prediction, and you've seen this before. Define the root mean square error, and we return it and we print it. So this is the train and in fact evaluate model file. So this is not just training, it also has very small evaluation side. Why very small? Because it's just looking at one model and one root mean square error. In reality, again, you do a grid search, look at multiple hyperparameters, multiple models, and you compare many RMSEs or R squared or different metric that you're using for evaluation purposes. So in practice, this is going to be a little comprehensive than what we have it here. But let's imagine for training and evaluation, this is acceptable. Now you can use some sort of a scheduler that runs on weekly basis or monthly basis or whatever is in your need, and runs this file, which is gonna load some data and train it, and it's gonna save or dump models and scalars and I don't know, encoders. Now imagine we like the process of training and evaluation, and we have scheduled this Python file for training, let's say on weekly basis, and now we're going to look at a predict.py, which in reality you want to predict, maybe it's a daily prediction or again weekly prediction or whatever, different schedule. But what it does is similar to what we have done partially on training, because the cleaning side should be very similar, like load the data, prediction data, and filter it for the same city. You have trained on one city, you should predict on the same city as well. Load the encoders, you should use same encoders again. You cannot use another encoder, and do the transformation and set the same index, and do basically same stuff that you did in cleaning of training data set, and return the xpredict. So there's no validation or test here. We just want to return the predict data, which we don't know the ground truth or label for, because these are supposedly live data coming, and we want to produce the prediction. So we clean the data and then we predict weather. For predict function, the first thing, we load the model. Again, this should be easy for now, but in your application it can load from S3. Either you have zipped the models or everything and you put it there. Then when you are loading it, you should unzip the models or do whatever that serves you better. But for the simple example, it's just loading from the local place, and then use that model that you've loaded with predict method and the data that you've already cleaned and you have imported through the argument, and then produce the prediction and predict the predictions. So this is going to be the whole process of train and predict in practice. If you like this prediction, also you need to schedule it and do it on daily basis or whatever time frame that you have in your mind. Okay, and that concludes our discussion on creating MVP for ML products. I will put the Git repo link in the description below. So if you had any questions, feel free to comment it, and I'll try to address those in timely manner. And if you also had any new ideas that you think more people are gonna enjoy listening or looking at that project, or yourself, you need some help on that, again, feel free to put it in the comment section, and I'll try to make videos on those too. Please subscribe to the channel to receive the notification for next MVPs that we are gonna create, and thanks for watching.